There are three ways of explaining the distribution of continents. A contracting Earth. This has no supporters at present. A steady-state Earth with fixed continents and oceans. Very few hold this view. A steady-state Earth with plate motion. Nearly all geologists believe this. Since about 1968, the plate tectonics theory has been the favorite with most geologists to explain the movement of continents. It seems that the theory can satisfactorily explain many major questions in geology. But there have always been doubters. One such man is Professor SW Carey, who supports the theory of an expanding Earth. Professor Carey was head of the geology department at the University of Tasmania for 30 years. He was also visiting professor at many universities, including Yale and Western Ontario. In 1956, he sponsored the highly successful Continental Drift Symposium at the University of Tasmania. This symposium helped stimulate interest in continental drift after decades of neglect or even contempt by the majority of geologists. He believed then, as now, that continents moved as a response to expansions of the Earth. But did he always believe that the Earth has expanded?
No, only during the last quarter of a century. During the 30s and 40s and 50s, I taught what you now call plate tectonics. I took for granted that the Earth's diameter was constant. It hadn't occurred to me anything else. But if I'd only known it, in Germany, Lindemann had published his book on expanding Earth in 1928, and Hilgenberg in 1932, and Kindle in 1940. But these weren't translated into English. They weren't translated until I translated them 20 years ago. But as I worked, I got increasing difficulty in putting the pieces together on a bigger and bigger area. You must remember that I was working more accurately than my contemporaries. I calculated hundreds of oblique stereographic projections, all by logarithms. There were no computers in those days. And I made comparisons on my hemispherical table. No matter how often I tried, I could never get all the continents to go together on the whole globe. Even with these, which fit so nicely, there's still a small gap there. But as I put more and more pieces on, the gaps accumulated, and I've got a very large gap. I didn't realize that my trouble was that my table matched my globe, and not a smaller globe, which was the proper globe for that time. As difficulties increased, I gradually became convinced that the plate tectonic model, which fits so well for these two continents, won't work for the whole globe. Then there's the problem of the Pacific Ocean. When you put all the continents together on Pangaea, Pangaea spills over a hemisphere. Here is Wegener's 1915 version of it. 70 years ago, Wegener pioneered continental drift, and the translation of his book from German in 1924 burst like a bomb among astonished English-speaking geologists. Wegener's map is an Eitoff projection of the whole globe, as though you cut the globe along the back and pulled the sides out and flattened it. Flattening, of course, pulls things out of shape. And this line is in fact the correct hemisphere on this projection. You can see that Wegener's Pangaea spills over the hemisphere just a little. Here is my version of it from 1945, 30 years after Wegener, drawn on a stereographic projection which shows only one hemisphere. Here again, Pangaea is just a little more than a hemisphere. And here, another 25 years later, is the 1970 version by the Americans, Bob Dietz and John Holden, using a similar projection to Wegener's and plotted by computer. Again, you see that Pangaea is just a little more than the hemisphere. So everybody agrees that Pangaea was just a little bit more than the hemisphere. Therefore, the Pacific, which was on the other side, was just a little bit less than the hemisphere. Everybody that has put the continents together on a globe with a present size finds that Pangaea has spilled over a hemisphere just a bit. That means that the ancestor of the Pacific on the other side of the globe must have been just a little bit less than a hemisphere. But since then, Pangaea has greatly increased in size by the opening of the Arctic and opening of the Atlantic and the Indian Ocean and Southern Ocean, so that what was Pangaea is now nearly doubled in size. That means that the Pacific should have been reduced nearly to zero. But the Pacific is still nearly a hemisphere. Now, that's absurd unless the Earth's greatly expanding. Now, on Pangaea, this point was close up to that point. So that this part of the Pacific Rim has increased by over 1,000 kilometres. Likewise, Antarctica was nudging Madagascar on Pangaea. That means that that part of the Pacific Rim has increased by a couple of 1,000 kilometres. Likewise, Australia was right up against Antarctica, and the ocean between has opened by 3,000 kilometres. Now, when you add them all up right round the Pacific, you'll find that the rim of the Pacific has greatly increased in length. That means that the area of the Pacific has greatly increased. But according to plate theory, and to take in the increase of Pangaea, the Pacific should have greatly decreased. This is absurd unless the Earth has greatly expanded. Then you've got the floors of the ocean. They're all very young. Very little of it is older than 100 million years, anywhere in the world. None older than 200 million years. And that's only a 20th of the age of the Earth. Where are the old ocean floors? The plate people say that they've been subducted. Did they ever really exist? Fossil and paleomagnetic evidence shows that the Permian equator went through Texas and New York. And at the same time, the Permian equator was just south of France. Now, that means that North America has moved up by 35 degrees towards the Arctic since the Permian, and Europe has gone up by 40 degrees towards the Arctic, and the same way Siberia has moved up by 20 degrees. So here we have a position of all the continents converging on the Arctic by 5,000 kilometres, which should have squeezed the Arctic by that amount. Was the Arctic squeezed that time? No. Through all that time, the Arctic has been a tension expanding area. The same impossibility comes quite independently from the Triassic, the Jurassic and the Cretaceous. Plate people claim that the Himalayas, or Himalayas if you say it that way, were formed by the movement of India 5,000 kilometres northwards to shove into Asia, folding up the Himalayas and opening the Indian Ocean behind. Two facts prove this wrong. First, the Paleozoic and Mesozoic strata in the Himalayas, Tibet, Siberia, Afghanistan and Iran all show that there was no ocean between India and the rest of Asia, only shallow intracontinental seas with similar fossils and rock types spreading right across. This Triassic reptile, whose lifestyle was like a hippopotamus, walked from India to China and back again, along with many others. Do you think this possible if there were 5,000 kilometres of ocean between? No. India was no further from China then than now. The great folding and orogenesis and uplift of the Himalayas did not commence until the Miocene, whereas the opening of the Indian Ocean commenced 150 million years before that and was largely complete before the Miocene. Plate tectonics can't explain the Himalayas. The paleogeography is all wrong, the timing is all wrong. This is a map of the Atlantic seaboard of North America, from Florida up to Greenland. Now, the fossils of the lower Paleozoic in here are so very different from the fossils on this side of the line. Even to the same age and in the same environment, these are so different that everybody agrees that they couldn't have been close together like that at the time they lived. So the plate tectonics people require that this line represents a wide ocean, and that these rocks were way over here, some thousands of kilometres away, and eventually closed with the swallowing of the whole ocean along that line. So that line is all that is left of the ancient ocean. Now, if this were true, when the continents were separated, these rocks would record their pole, and these rocks would record their pole, which would be the same pole. And as the continents moved together, those poles would move apart by the amount of the motion and in the direction of the motion. Now, do we find that? No, in fact, we don't. We find a wide separation, but separation is in the direction of the suture. Not closing like that, but moving along the suture. Now, before that suture was moved, England was right down here, very close to where Florida is now. And Florida and the Maritime Province rocks were still further along in that direction. Now, the motion was that England moved right up here, 5,000 kilometres to that position, and it brought these rocks into close contact with those. The closure along this suture was not due to the motion of two continents together, as tectonics people claim, but the movement along the suture. As I said before, all the ocean crust is of very young age. Now, if we take that crust out to see what it was like before, we find that all the continents will completely enclose an Earth half the diameter with no oceans at all. Now, when Dr. Embleton and Dr. Schmidt of the CSIRO were studying the paleomagnetism of the Proterozoic rocks some 2,000 million years ago, they found to their surprise that the continents were in the same radial position as they are now. In other words, the continents have moved apart, not by sliding on the surface, but by moving out radially. Now, that is exactly what my friend Klaus Vogel of East Germany found when he fitted the continents together on a small globe inside a transparent outer globe of the present-day Earth. As he progressively eliminated the oceans, the continents converged as they went back in along the radius and fitted together on a globe half the size, enclosing it completely. Now, Dr. Andrew Glikson, a geochemist of the Bureau of Mineral Resources in Canberra, has been studying the missing Archean crust. Missing only if you assume that the Earth has always had its present diameter and always had the great oceans. But Dr. Glikson concluded that it was not missing, that the present crust was all there was of continental crust and fitted together on a small Earth. Dr. Keith Crook of the Australian National University has drawn attention to the lack of ocean-type sedimentation before the Paleozoic. This could mean the lack of oceanic environments before the Paleozoic. In other words, the great oceans as we now know them didn't exist until fairly recent times. Of course, most geologists do reject ideas of Earth expansion, but in fact, very few of them have studied it. This is not surprising because when you come to think of it, no scientist could possibly read even the abstracts of all the papers in his own field. And because Earth expansion has been generally discarded, these are the first papers which they don't read. Dr. Peter Smith of the Open University in Britain polled a large number of geologists, and he found that not one of them had studied my book on Earth expansion. Of course, some have studied it, and some have risen to defend the orthodox views. Some point out, for example, that if all the continents were brought together and so that the Earth was half its present diameter, then the weight of objects on the surface would be 4 times their present weight. Well, Dr. Stewart, or Professor Stewart of Reading University, has demonstrated that the gravity force on the surface of the Earth could not have been as much as that. But Professor Stewart's argument assumes that the mass of the Earth has been constant. Well, has it? I don't think so. I think that all matter in the universe grows at a rate depending on some power of pressure and time. Then others point out that if the Earth was shrunk to half its diameter with only the continents, they would be drowned to great depths by all the ocean water. There'd be no land surface at all. But this assumes that the water was always there. Was it? I don't think so. At a very early stage in the Earth's history, the Earth lost all its water, all its gases, all its vapours. And our present atmosphere and the present oceans have accumulated through geological time, partly from emanations from volcanoes, but mostly from the new volcanic rocks coming up on the ocean floor for the growth of the oceans. So that there's a direct link there. The volume of ocean waters has kept in step with the area of the oceans. Some have asked, why is it that the Earth, of all the planets, is the only one that shows expansion? But if you look, they all do. Take Mercury. Mercury has a polygonal fracture pattern of a couple of 100 kilometres, which is exactly what I think the Earth was like at that time. That's just what the expanding Mercury should have been like at that stage of its development. And now Mars. This great equatorial rift zone on Mars is exactly what I think the Earth was like 2,000 million years ago. Then the asymmetry of all the planets and of the Moon, I think that is due to their expansion. Some critics have pointed out that if the Earth was expanding, the number of days in a year should increase as the rate of rotation slowed down. Well, now, fossil corals and some other animals have growth lines, some of which are thought to be daily, and some of which are thought to be monthly, and some annual, like tree rings. Now, if you count the number of daily ones between the annual ones, you shouldn't know the number of days in the year. Well, now this has been estimated, and I say estimated because the daily ones are so very, very fine that it's hard to be sure whether you've missed 3 or 4 here at various places. Nevertheless, it's quite true that there were many more days in the Devonian year than at present. But that has been interpreted in terms of the tidal drag of the Moon slowing down the Earth. But these calculations depend on the assumption that the mass of the Earth has been constant. And as we've already said, I doubt that this is true. Paleomagneticians have also tried to estimate the ancient radius of the Earth by measuring how far various paleolatitudes were from the pole of the time. Now, individual results scatter very, very widely, but by combining a large number of them, we hope statistically to get the correct result. Well, now, the error here is not so much in the statistics, but in the assumption that as a continent flattens to a larger radius Earth, that the angles to the pole remain constant. You all know that the angles of a plane triangle add up to 180 degrees, but the 3 angles of a triangle on the surface of a sphere add up to something between 180 degrees and 540 degrees, according to the ratio of the size of the triangle to the radius. Hence, the angle between 2 meridians of longitude painted on the surface of a continent, each pointing to the pole, would get smaller as the Earth expands, and still point to the more distant pole, thus continuously cancelling the evidence that the Earth is expanding. Still larger errors come from the map projections used by the paleomagneticians for their calculations. When you make a map of the spherical surface on a flat paper, shapes must distort severely. You can't flatten a sphere without distorting something. You can draw a map so that all the areas are correct, but only with great distortion of shape. Or you can draw a map to keep shapes correct, but the areas are way out. Or you can have the angle and distance from one central point correct, but both shapes are wrong, as on this one. This quadrangle here has the same area and shape as that one in there, although they're different on the projection. In drawing the continents, you have a wide choice, but the expanding Earth did its own thing, and you've got no choice at all. It didn't hold angles strictly correct, it didn't hold shapes strictly correct, or areas strictly correct. But the paleomagneticians, They started off by using an azimuthal equidistant projection, which has quite large errors as you move away from the centre. They improved a bit by using an azimuthal equal area projection, but still the errors are large, and especially away from the centre, and their computer program biases in favour of the points furthest away from the centre. And the paleomagneticians claim that their results prove that the Earth is not expanding. But in addition to these geometrical errors, they ignore all the billions of fractures, large ones and small ones, right on down to the smallest joints. Now, if each joint only yielded by 1/1000th of a degree, you could accumulate 10 degrees of error in 1 kilometre. It's all like this picture puzzle of the vanishing square. Here we have two identical rectangles, 12 squares by 5 squares. And this orange triangle is the same as this one, and this blue triangle, which is 7 by 3, is the same as this one, which is 7 by 3, and this green one, which is 5 by 2, and same as this green one, which is 5 by 2, and this purple area with 5 underneath and 2 on top is the same as this purple area with 5 underneath and 2 on top, and this yellow one with 5 on top and 2 underneath, the same as this one with 5 on top and 2 underneath. Where does the black one go to? Well, it's very simple. If you look at it very closely, you'll see that the tangent of that angle is 2/5, and the tangent of that angle is 3/7, which is not quite the same. And in fact, there are 12 little tiny pieces that are ignored just along there, and they add up to the area of the black square. By ignoring billions of tiny adjustments like this, the paleomagneticians claim to have proved that the Earth is not expanding. In this they join Harold Jeffreys and George Gaylord Simpson and Bailey Willis, three of the great leaders in their own fields who ridiculed continental drift, and by their very prestige delayed the acceptance of continental drift for some decades. Expansion is just one step forward in the progress from early Greek science, when everybody knew of their flat Earth in the centre of the great universe, with the moon and the sun and the stars and the planets all going round the Earth. Then Pythagoras, about 600 BC, was the first to prove to himself that the Earth was a sphere. But Zeno, his successor, laughed at such a silly idea. Think of the people underneath with their feet pointing upwards and the rain falling upwards. How silly. By 300 BC, Aristarchus of Samos was the first to show, to his satisfaction, that far from being the centre, the Earth itself went round the sun, which was the centre, along with all the planets and the stars. But Ptolemy, he proved with very good formulae whereby he could predict the paths of planets, he proved that no, the Earth was the centre, and moon and sun and planets all went round the Earth. And this view prevailed for another 2,000 years, until Copernicus re-established what Aristarchus had known 2 millennia before him, and he nearly lost his head for it. It was into this century when people all knew that the continents were fixed on the face of the Earth. And it's only in the 60s that it's generally been accepted that the continents have moved over the surface of the Earth relative to each other, even though Wegener knew this 50 years before. And now it's 50 years since Hilgenberg and Lindemann knew that the Earth was expanding. And now it's your turn to realise that the Earth is expanding. May I quote from Alexander Pope? "Be thou the first true merit to befriend, his praise is lost who stays till all commend."